Hello everyone. Today I am going to deliver lecture 2 of moving charges and magnetism. Okay students, our topic is now application of Biot-Savart'S law. The first application, magnetic field due to straight current carrying conductor. This application is very important for CHSC examination as well as your entrance. So listen me carefully. For this long question, you have to remember only 2 points. 2 points is sufficient to understand about the long question, which is very important. Number 1, you have to clarify the figure of this long question. I will draw the figure and you listen me carefully. Then second point, I will tell you later on after 10 minutes. So only 2 points you have to remember. Okay students? So what is our long question? Magnetic field due to straight current carrying conductor. Let this is your straight current carrying conductor. Let. And you know a field around it, magnetic field around it. At this point, you have to find magnetic field. Okay students? This is a straight current carrying conductor and here magnetic field around it, you know it. And let at this point or at this point or at this point you have to find magnetic field. For that we will draw the figure. Listen me carefully about the figure. Okay students, let this is your AB straight current carrying conductor. Okay students, this is the point P where you intend to find out the intensity or magnetic field. This is a straight current carrying conductor and this is a point P where you find intensity. So target is what? To find intensity at this point, to find magnetic field at this point. So you have to know about the points. You have to identify the point. You have to locate the point, where the point is. Let this is the perpendicular distance from straight current carrying conductor. Perpendicular distance from straight current carrying conductor. And this instruction for location of point P is not sufficient. Why? Because if point P is here or if point P is here, this is also perpendicular distance R. This is also perpendicular distance R. So only this instruction, perpendicular distance from the straight current carrying conductor is not sufficient to identify or to locating the point P. So what we will do? And you remember the field at this point, that means magnetic field at this point are different from each other. So you know our target is to find out the intensity or magnetic field at this point. Okay students? So to locating, you know, this distance, that means this perpendicular distance is not sufficient to identify the point P or to define P. So what we will do here? There are 3 terms to identify the point P. What are the 3 terms? This is one term point P. Now you draw a line from B to P. Let this is theta 1. That means angle of this is angle theta 1. This is angle theta 1. This is your theta 1 and this is your let theta 2. It is your angle of elevation of point P. This is your angle of elevation from point A to point P. Angle of elevation theta 1. It is angle of elevation theta 2 from point A and point B. That means A has a elevation theta 1 from point P, theta 2 from point P, and B has a elevation theta 1 from point P. With the help of these three terms R, theta 1 and theta 2. With the help of these three terms, we can easily define point P. Otherwise, it is incorrect. Okay, students? Now, if the length of A is increased, that means AB is increased, the intensity at this point is different. If B is also increased, the intensity at point P is also different. If point P is at different points, that means position of P at this point, it is also different magnetic field. Okay. So, you know, target is what? To find out the magnetic field due to straight current carrying conductor. With the help of Biot-Savart'S law, we can know how to find the magnetic field due to current carrying conductor. You take small section from the straight current carrying conductor. Let that small section is DL. Here number of small section. You take this one, small section. What be the midpoint of the small section? Okay. You draw a line from O to point P. Let this is the angle alpha and this is the angle theta. Why? Because to define DL, we have to take a length. We have to take a length L from M. The distance of DL from M is taken as L, and this is the angle created. It is what? It is what? It is the direction of. It is the direction of current, and this is the distance from midpoint. That means from small section to point P, and the distance is taken as X. And the angle between this distance and this distance, that means direction of current, and this distance is taken as theta. Okay, students. So you know all about the picture. This is all about the picture. Okay, students. I have drawn the picture here. I have drawn the picture here, and we will explain about the picture. We have to write the explanation about the picture first. Here you write, what is this picture? You know, AB is a straight current carrying conductor. DL, small section of it. O be the midpoint of the small section. P be the point where we intend to find out the magnetic field. R, you know, perpendicular distance from point M to point P. X, distance from point O to point P. And OM, you know, this is the length OM. and MOP is equal to theta. MOP what you know? Angle between what? Direction of current DL and OP. OPM is equal to alpha. This is OPM. OPM is equal to alpha. And theta 1, theta 2, you know. Theta 1 what? Angle of elevation of point P. Theta 2, angle of elevation of point P from A. Okay, students. This is all about the figures. You know, according to Biot-Savart'S law, how you find the magnetic field at point P. Biot-Savart'S law tells us to find out the magnetic field due to small section of the current carrying conductor. Small section. So let dB is equal to, you know the formula, mu naught upon 4 pi ideal sin theta by x square here. Because you know mu naught upon 4 pi ideal sin theta by x square. So mu naught is your constant value, 4 pi is your constant value, I you know current flows through the conductor, dl small section of it. Here theta means what? Theta is the angle between, as per Biot-Savart'S law, theta is the angle between dl and the distance from dl to point P. That means where we intend to find out the intensity. And x, you know, distance between O to P. That means dl to point P. This is x, as per Biot-Savart'S law. Okay, students. I told earlier, for understanding this long question, you have to remember only 2 points. Point 1 what? To know the figures, to clearly understand about the figure. Point 2, listen me carefully, just you have to find the value of dl, that means theta and x square. This is point 2. Find the value of dl, sin theta, x square. After finding the value of these 3 terms, you put it in equation 1. Let it is equation 1. Okay, only 2 points. Again I will repeat it. First you have to know clearly about the pictures. Second one, I will write the formula of Biot-Savart'S law and find the value of these 3 terms, because these are unknown, dl, sin theta, that means theta and x. This is the remembering point only. Okay. Now how I will find first sin theta, the value of sin theta, that means theta. Okay. To find out theta, you go through this triangle. Okay. In triangle OMP, you know, sum of these 3 angle is 180. Sum of these 3 angle is 180. Since it is 90 degree, so sum of these 2 equal to 90. So theta plus alpha is equal to 90. Okay, students. Now theta is equal to what? 90 minus alpha. Taking sine on both sides. Sin theta is equal to sine 90 minus alpha. Okay. Now sin theta is equal to cos alpha. Equation 2. It is equation 2. So already we got the value of theta. That means sin theta. Now you find the value of x. Again you go through same triangle. Again in this triangle you observe this is angle what? Alpha. Okay, this is theta 2. it is alpha. For this triangle, this angle is alpha. So you take cos alpha here. Cos alpha. Cos alpha is equal to what? Cos alpha is equal to MP by OP. Cos alpha is equal to MP by OP. MP by OP. MP means you know R. OP means what? X. From that, X is equal to R by cos alpha. This is equation 2. Now we got the value of X also. Now only remaining is DL. To find out DL, to find out the value of DL, what we will do? Again in the same triangle, that means in OMP, you find tan alpha. Again, tan alpha. Tan alpha is equal to OM by MP. You know, OM by MP. OM means the length of OM, L, and MP means R. By cross multiplication, you get L is equal to R tan alpha. Okay, students, R tan alpha. Now, target is what? To find out DL, not L. So, differentiating both sides with respect to alpha of this equation. Differentiating both sides. That means DL by D alpha is equal to dr tan alpha by D alpha. From that, what we will get? You observe here, R is a constant taking outside. So remaining is what? D tan alpha by D alpha. That means sec square alpha. R sec square alpha we got. From that, DL is equal to R sec square alpha by cross multiplication. It is D alpha. Let it is equation what? 3. It is equation 3. Sorry, it is equation 3. It is equation 4. It is equation 4. Okay. Now you observe here. It is equation 1, which is the formula for Biot-Savart'S law. Now equation 2, value of what? Sin theta, and that means theta. Equation 3, value of x. Equation 4, value of dl. Now you write putting the value of equation 2, 3 and 4 in equation 1, or use equation 2, 3 and 4 in equation 1. In equation 1 we get dB is equal to mu naught upon 4 pi I dl, you know, R sec square alpha d alpha, R sec square alpha d alpha sin theta cos alpha upon x square means R square cos square alpha. Okay, students. So our second point, what you remember? First point, to know about the picture. Second point, write the Biot-Savart'S law and find out the value of only dl sin theta and x. dl sin theta and x. And how we will find dl sin theta and x? Theta, you know, sum of these two angles equal to 90. From that you find easily theta. Second, how you find x? in this triangle you write cos alpha and put the formula, you will get it. Similarly, for DL, again in the same triangle, you write formula for tan alpha and differentiating, you will get the answer. After getting these three equations, you use equation 2, 3 in equation 1. We get. That's all. So after getting dB, you simplified mu naught upon 4 pi. You remember here, when you take in above sec square alpha, cos square alpha, when it move to numerator, cos sec square alpha, cos square alpha is equal to 1. So r, here r square. So remaining is what? I, here only the remaining is what? Cos alpha d alpha upon r. By simplifying, you will get this one. Okay, students, this is your what? This is your what? Magnetic field at point P due to small section dl. How we will get the total? How we will get the total magnetic field due to straight current carrying conductor? Okay, students, you know, by integrating we will get this. By integrating both sides by taking suitable limit. It is your dB mu naught I upon 4 pi cos alpha d alpha upon r. Okay. So here lower limit is what? Theta 1 and upper limit is what? Theta 2. Theta 1 and theta 2. It is 0 to B, it is theta 1 to theta 2. Okay, students, it is where you got B. Now the constant mu naught I 4 pi r, all are constant taking outside. Mu naught I upon 4 pi r, the remaining is only what? Theta 1 to theta 2 cos alpha d alpha. Okay, students. Now B is equal to mu naught I upon 4 pi r. By integrating you get what? Sin alpha. Okay. And by using your lower limit, upper limit, at last you will get sin theta 2 minus sin theta 1. Okay, students. By putting the lower limit and upper limit, first you put the formula cos alpha d alpha is equal to sin alpha, and after putting the lower limit and upper limit, you will get sin theta 2 minus sin theta 1. This is your derivation of magnetic field at point P due to straight current carrying conductor. Okay, students, you by heart the formula mu naught I upon 4 pi r into sin theta 2 minus sin theta 1, and you know what is theta 2 and theta 1. Okay, students, now special case. If the straight current conductor is infinite, okay, straight current carrying conductor is infinite, then what is dB? Then what is B? What is magnetic field at point P? That means this AB, you observe here, this AB is infinite. That means it is infinite. Okay. Then you observe here, if A is at infinite, that means it is at infinite. You know, when the point A is the top of the conductor is at this point, the angle is what? Theta 2. Okay, theta 2. If it is at infinite, what is it makes an angle with infinite? That means when point A is at infinite, the angle is what? this side. If the point A is at infinite, it makes an angle 90 degree, okay, or pi by 2. Similarly, when the point B is at this place, your angle is this one. If B is at infinite, you remember, if B is at infinite, then if B is at infinite, it makes an angle what? 90 degree. Okay. Now the condition, if for what? For infinite. Infinite what? Current carrying conductor. Infinite current carrying conductor. For infinite current carrying conductor, you know, theta 1 is equal to minus pi by 2 and theta 2 is equal to pi by 2. Okay, students, now putting the value of theta 1 and theta 2 in this equation, we will get the answer. So B is equal to mu naught I upon 4 pi r. Instead of theta 2, you put the value of pi by 2. Okay, sin pi by 2 minus sin theta 1. Instead of theta 1, you put minus pi by 2. Okay. Here you observe the sign of theta 1 is negative because it is the downward and theta 2 is upward. That is why you take theta 1 as the negative sign. Okay, students. Now B is equal to mu naught I upon 4 pi r, and you know the value of sin pi by 2, that is 1. Okay. Now sin minus theta is equal to minus sin theta. Here minus sin theta minus, you will get the plus, and the value of sin 90 is equal to 1. Okay. B is equal to mu naught I upon 4 pi r into 2. Now 2, 4 cancel, you will get mu naught I by 2 pi r. Okay. This is your answer of magnetic field due to infinite long straight current carrying conductor. Okay. B is equal to mu naught I upon 4 pi r. Okay, students. Okay, thank you.